For the short circuit, I must check these pins. These pins are the main 12 volt input for the motherboard, and this power supply goes directly to the FETs for the main power rails of the CPU and GPU. So let's check it first. This one is ground and this is the positive point, and it shows 2.6 ohm. It means that it is really short circuited. So we have to further disassemble it and have to unscrew more screws to get this motherboard out from this fan and heatsink assembly. So I have unscrewed the clamps too, so that we can take this metal plate out. And here first we have to unjack the fan jack. Yes, it is already done, and here it is. And physically it shows that nobody has touched it. Okay. So thermal paste has also been dried out. We'll see it later, and now I will show you the error. As you have seen that these points are short circuited, so first of all I will tell you that this input of 12 volt, positive 12 volt, are directly connected with this coil and this coil. These two inductors are filtering the PSU positive 12 volts, including these two capacitors and these three ceramic capacitors, to give the power of 12 volt to these FETs. This one, this one, this one, this one, and 4 of them. So let's check it. It is direct. It should be directly here. I don't know why you can see it properly. Yeah. So let's check it. This point, the input of 12 volt positive is directly goes to this coil. As you can see that it is, and also on this coil. Yes, the 0.4 ohm means that it is direct, and if I check like this, it shows 2.6 ohm. It means some of the component is giving the short circuited value of 2.6 ohm. So after this, it goes directly to these FETs. These 12 volts goes to these FETs. So there must be a short circuited FET. So for this I will put a negative probe of the meter at the ground and the positive on the gate of the FET. It is showing at the value of 15 ohm. It is very low. And the second FET's gate is showing 10 kilo ohm. That's fine. Now if I go to the next FET, this is the primary FET. It is at 19.69 kilo ohm, and the second FET gate is 10 kilo ohm. It means this FET gate is short circuited. So let's check the remaining 12 volt related FETs. Here I will check the gate. It is fine, it is acceptable, and this one is also acceptable, and the second FET here, gate input 10K, and this one is 10K. Fine. So guys, this FET is suspicious. We have to separate it from the motherboard, and I will check it. For this I will apply some flux on the sides of it, this FET. Let's separate it from the circuit. Hopefully that is the only reason for this error. After removing this FET, we must check the logic of the gate input, because the reason of shorting this FET could be the coupling resistor from the PWM chip that gives the oscillations or switching on the gate of this FET. We must verify it. It took a long time because this PCB from Sony sucks a lot of heat. Yes, now it is apart. And if I let you check the logics of this, I will put it here. And if you can see the both the meter and the FET would be fine. Yes, it is. Here we will check. This is the drain and this is the source. Yes, it is short. And this is the gate. Yeah, the same reading, 14 ohm. This gate is also got short, and it is short. So we must verify the input gate pin of this FET. For this I will go to my logic tester, or we can verify it here too, that we can also verify it here that it should not be short. This is the gate pin and it is 20 kilo ohm. It looks fine. If it looks fine, for more confirmation I must check it with my logic tester. Putting the one from the oscilloscope is ground to the ground of the motherboard, and here is the logic. It should take a curve from top, it should take a curve. Most probably I have to disconnect the cell from the motherboard for this check. Yes, and now I will check it again. Yeah, you can see that there is a little curve at the top of this curve. Yes, it's fine, and no resistance here. It is also with a curve, should be a curve. Yes, the top of this, it is curved. Check it again here, it is curved. Okay, fine, let's change this FET without checking anymore and putting the cell back into its socket. I have a lot of scrap of these motherboards, so I don't need to purchase a new FET. Let's take it from here. Yes, I will get this one. Though it relates with the GPU supply of this motherboard, but it will work for us. Yes, I got it, and I will put it here. It sticks. No problem. Yeah, that's fine. I have changed this FET and it looks fine. So, and if I check the reading for the gate again here, now it is in case 20 kilo ohm. You can see here, yes. And on the other side here, this connector reading is now in infinity, omega ohm. Yes, now the shortage has been fixed, and let's check it with the power supply. Here I will check it with my workbench power supply first. And that is here, and put the jack, 12-volt jack here, and the standby volt jack here. Power on, and here it is. Oh my god. I set it with my own workbench power supply, and the status is that it is turning off after a while. Short has removed, but I observed that there should be oscillation here, but there is no oscillation and no output volts. Nothing is there. So volts are available, 12 volts are available. Should I give some pressure to the CPU? No. So I will connect a ground with this motherboard from my oscilloscope. and try to observe the remaining error in this console. This is the PWM chip for the processor, the CPU power supply. I have to check the coupling resistors here. 2.7, 2.5, 2.5, these are fine. 5K, 149, 117.5. And check the rest, these are fine. This one, it shows 1.7 meg, that's not good. And it also turned into 12 mega ohm. These two resistors are not fine. So we must verify it with the good board. This model is JST001. Okay. Here I have found the motherboard of same kind or same type, JST001, JST001. So I need this resistor. It is 35.7 kilo ohm. I think that these three resistors are giving the wrong reading. So if I replace only this resistance, maybe all would be set. Fine. So let's try it. Here I should also apply some flux paste. And let's try it. Oh my God. Yes. Yes, that's fine. Let's check the biasings for this chip. Actually, these resistors are the biasings from the CPU and the feedback from the CPU. So the biasings must be accurate in any case. So let's check it here again. It is 221 kilo ohm, and here it is No, this is even not good. Okay, let's check the remaining. It is at 35 kilo ohm. And this one is at 1.98 kilo ohm. 35 kilo ohm, 1.98. So we must replace this one. This should be at 220 kilo ohm, but this one is still 0.5 mega ohm. No, it is 200 kilo ohm. I hope it could be fine. Let's check it again. Here it is on red standby light and I'm turning it on, and now it is on. Yes. Hopefully now the fault is rectified, and hopefully we can see the display. If it shuts off with 6 beeps, then hopefully it will be all set. And here if I remove this heatsink, yeah, it's just getting hot. It shuts off with 3 and 3 more beeps. Yes, it's fine.